Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to perform one-way Anova using STATCRAFT. But even before I go ahead and demonstrate how to perform one-way Anova using STATCRAFT, I request all of you to like, share, subscribe, and press the bell icon. As you can see here, I've got retail data consisting of two columns. The first column is shopping for, and the second column is amount of money spent. If you look at the first customer, he's shopping for himself and he has spent $416. Second customer again shops for himself and the amount that he spends is given. Third customer is shopping for himself and family. The fourth customer shops for himself and spouse. As you can see here, there are three sets of customers. One set of customers shop for themselves. Another set of customers shop for themselves and family. And the third set of customers shop for themselves and spouse. Anova. Anova stands for analysis of variance. It is used to compare three or more than three groups. As you can see here, since we have got three groups, we would like to compare whether the average amount of money spent across these three groups is the same or different. This is where Anova is very helpful because, as I said, Anova is useful when you want to compare for three or more than three groups. As a first step, what I'd like to do is show you exploratory data analysis through a bar chart. And as a second step, we can go ahead and look at how to perform Anova using STATCRAFT. Firstly, let's begin with EDA. Let me click on the analysis tab. You see a lot of options the moment you click on the analysis tab. Let me scroll down and choose the option graphics. There are two options. One is called as graphics and the second one is what is called as advanced graphics. I would like to choose advanced graphics. Within advanced graphics, you see three options. First is a bar plot. Second is scatter plot. The third one is histogram. I will choose the first option, namely bar plot. As you can see here, the moment I choose a bar plot, you will be able to see a new dialog box. Now, in this dialog box, what you can do is you can specify the X variable as well as the Y variable. In the X variable, what I'm doing is I'm specifying the categorical variable, which has three groups, namely, who is he shopping for? The Y variable here will be amount of money spent. The measurement variable is mean. What this does is it will give you the average amount of money spent for the three groups of customers. Let me go to the options tab and I'll choose the option horizontal bars. You can change the color if you want to. Let me click on the drop down menu and choose the option fill. By default, you will get a black color. So let me choose a different color here and click on OK. It takes a couple of moments for STATCRAFT to run the analysis. As you can see here, STATCRAFT displays the R code that it is using to come up with the bar chart. As I scroll down, you can see a bar chart here. There are three groups: people who shop for themselves and spouse. Secondly, people who shop for themselves and family. And thirdly, you can see people who shop for themselves. And here you can see it is plotting average amount of money spent. Visually, when you look at this particular chart, it is quite obvious that people who shop for themselves and family tend to spend a lot of money. In fact, on an average, they are spending $500, which is on the higher side. The next big spenders would be people who shop for themselves and spouse. In fact, they're spending slightly above $350. People who spend the least are people who shop for themselves. So the big spenders are people who shop for themselves and family. The next highest spenders would be people who shop for themselves and spouse. And thirdly, people who shop for themselves would be the third biggest spenders. Now, this is as far as a bar chart is concerned. The question is there a statistically significant difference among these three groups? To verify whether there is statistically a significant difference or not, what we can do is we can go ahead and proceed to perform Anova. Let me now click on the analysis menu. Here, the moment I click on analysis menu, you can see different options here. I will choose the fifth option from the top, namely compare groups. I'll click on the drop-down menu. The second option from the top here in the panel is Anova. You can see a drop-down menu. Let me choose the drop-down menu and choose the very first item, namely one-way analysis of variance. As you can see here, in the variable list, I am entering the scale variable, namely amount of money spent. And in the factor list, I am specifying the categorical variable. You can click on the options tab and choose to perform homogeneity of variance test. You can choose to perform either the Levens test or the Bartlett's test. Further, if you want to perform a pairwise comparison, you can choose what is called as the post hoc test. By default, I have selected here the Tukey's HSD. Once you've made these selections, you can go ahead and click on OK. In the output tab, what you see here is one-way analysis of variance results. You can see here shopping for and residuals along the row, and you see important columns like degrees of freedom, sum of squares, mean square, the F statistic, and the probability of F value. When you take the sum of squares value and divide it by the degrees of freedom, you will be getting the mean square. This is true for both the rows, namely the categorical variable as well as the residual variable. When you take the ratio of the mean squares, what you will get is the F statistic, and the p-value is computed for the F statistic here. As you can see here, the p-value is very, very small. It is less than 0.05. Since it is less than 0.05, we reject the null hypothesis and conclude that there is a significant difference in the amount of money spent for the three sets of customers. Further, if you want to do a post hoc test, you can look at the results of the post hoc test. In the first row, you have a pairwise comparison between people who shop for themselves and family versus people who shop for themselves. You can see here the average difference in spend is $161, and when you look at the p-value, it is 0, which is less than 0.05, indicating that there is a significant difference in the amount of money spent for people who shop for themselves and people who shop for themselves and family. You can see the same trend for all the three rows because the p-value is less than 0.05 for all the three rows, indicating that no two groups are the same. Each of these two groups and the amount of money spent by customers belong to this group is significantly different. So this is how Tukey's HSD helps us perform a post hoc test. With this, I've come to the end of today's video. In today's video, we have looked at what is one-way Anova, how do you perform a EDA for one-way Anova, and finally, we have looked at how to do post hoc tests. If you have liked this particular video, I request you to like, share, subscribe, and press the bell icon. Thank you very much for watching this video. Have a great day.